Assalamu alaikum, respected teacher and my dear friends. I'm going to present my presentation on the topic development of single cylinder diesel engine test bed for the investigation its performance characteristics. Contents, which these are the contents which include introduction, literature review, results and discussions, experimental setup, conclusions and future work and references. Introduction. Actually, diesel engines are one of the dominant prerequisites nowadays, and the emissions from the engines are very badly affecting the mankind. So, to overcome this, uh, diesel engine diesel engine researcher and specialists are trying to find a substitute fuel or alternate fuel which reduce the performance, which reduce the exhaust emissions and upgrade the performance characteristic of the diesel engine. So in this project we have uh, tested this engine, and we have focused on the performance characteristics of four stroke single cylinder Kirloskar diesel engine, and we have performed experiments and measured the performance parameters. And now talk of performance. What does performance means? Actually, the term performance usually means how well an engine is doing its job in relation to the input energy, or how efficiently it provides useful energy in relation to some other comparable engines. If we want to compare two engines, then the comparison will be done on the basis of performance parameters. The engine which are having better performance parameters will be better as compared to other engine, or engine performance is a sign of degree of success, and engine performance is compared on the basis of certain performance indicators. These performance indicators are known as performance parameters, and these performance parameters are load, speed, torque, brake power, brake thermal efficiency, specific fuel consumption, and exhaust emissions. So this is the working of four-stroke diesel engine. There is four strokes. First is one is intake stroke. In intake stroke, the air will be drawn inside the cylinder, and the piston will move downward direction, and the inlet valve will open, but the outlet valve will be closed, and the pressure of the air inside the cylinder will be lesser than the atmospheric pressure. After the intake pressure, there will be compression stroke. In compression stroke, the air will be compressed by the upward movement of the piston, and both the valve will remain closed. And after compression stroke, there will be fuel power stroke. In fuel power stroke, the fuel will be injected, and the air fuel mixture will be ignited, and by the high pressure of the air fuel mixture, there will be downward movement of the piston, and this in this stroke, power will be delivered by the piston to the crankshaft through the connecting rod. And after this fuel power stroke, there will be fuel exhaust stroke. In fuel exhaust stroke, there will be upward movement of the piston, and the exhaust gases will go out of the cylinder, and inlet valve will remain closed, and the outlet valve will open. Okay. Now talking of thermal efficiency. Actually, the thermal efficiency of the diesel engine is highest as compared to any other engine of either internal or external. Due to the high compression ratio of the diesel engine, the thermal efficiency of the diesel engine has the highest value, and low speed diesel engines can have a thermal efficiency which is exceeding up to 50%. So literature review. Many authors performed experiment on the diesel engine, and they used different kind of biofuels and other fuels and biodiesel blends, and they gave the their investigations as per the fuel used. So Camel and Vijay Balance 2015 performed an experimental investigation on a diesel engine. They used rice bran oil, biodiesel, and plastic oil, and conclude that the specific energy consumption of the rice bran methyl esters is more than plastic, where the thermal efficiency of the engine is lesser as compared to diesel when they used rice bran, biodiesel, and plastic oil. Okay, now Mahalingan 2018 found the outcome of doping pentanol to mahua oil, and they conclude that by adding pentanol to biodiesel, there was an increment in brake thermal efficiency of the engine, whereas brake specific fuel consumption was less as compared to pure biodiesel. And other author conclude so many investigation. Yadav 2016 investigated that biodiesel can be used in the engine without modification. We don't need to modify the engine. We can use biodiesel in the engine without modifying the diesel engine. Due to the properties of cottonseed oil, smooth operation is possible. So other authors given so many investigations as per the fuel used. But in our experiment, in our project, we used only diesel in the diesel engine as a fuel. After that, we will be using other fuels like biofuels and biodiesel blends. And other authors Sundar K and R. Uday Kumar studied performance of rice bran and cotton seed biodiesel blends in diesel engine, and they found that there is an increase in brake specific fuel consumption, and when the engine operates with both biodiesel blends, the performance characteristics like brake power and brake thermal efficiency are with very minimal difference, and this is due to similar properties tested biodiesel blends. And Bora and Sharma conducted test on diesel engine. So when Sharma conducted test on diesel engine, they found that with the increase of the compression ratio, brake specific fuel consumption increase and brake thermal efficiency decreases. So experimental setup. The experimental setup which we used in our project, it is used to evaluate the thermal performance of the engine, and the thermal performance are brake power, brake thermal efficiency, brake specific fuel consumption, and exhaust gas temperature. And the thermocouples are provided on the setup at different positions, and the simple diagram of the experimental setup is shown in figure 2. And these are the components of the setup, which include engine, hydraulic dynamometer. In our experimental setup, the dynamometer is a hydraulic dynamometer, and airbox, temperature indicators, U2 parameters, fuel tank. Okay, this is the schematic diagram of experimental setup. Experimental setup include engine and hydraulic dynamometer. This hydraulic dynamometer is connected through the propeller shaft, and there is a fuel tank in which fuel is filled, and there is a fuel meter which measures the fuel quantity, and there is a air box in which air is coming and air is outgoing, and there is a crank angle disc, and there is T1, T2, there are T1, T2, T3, T4, T5. These are the thermocouples. T1 is the thermocouple for measuring the inlet air temperature before turbocharging, and T2 is the thermal couple for measuring the outlet air temperature after turbocharging, and T3 is the thermocouple for measuring the temperature of the inlet coolant, and T4 is the thermocouple which will use to measure the temperature of the outlet coolant, and T5 is the thermocouple which will use to measure the exhaust gas temperature. and the setup used engine. So in our project, the engine which we used is a single cylinder naturally aspirated direct injection compression ignition engine of Kirloskar maker, and this is the table of the specification of the diesel engine. Okay, now hydraulic dynamometer. Hydraulic in our experiment there is hydraulic dynamometer. So hydraulic dynamometer is a device which is used to measure the force, torque or power produced by an engine, and it can also be used to apply load torque on the engine. And there are 5 thermocouples mounted on the setup which we have already discussed these thermocouples. Now U2 manometer. We are having three kind of U2 manometers. One is for the orifice meter, which will use the mass flow rate of the coolant, and second is air flow meter, which will use the mass flow rate of the air, and U2 manometer for the boost pressure of the after turbocharging, and there is a fuel tank. So these are the performance parameters. One is brake power. So brake power, it is the power which is available at the delivery point or at the crankshaft. So it also known as brake power or shaft power, and it is given by BP is equal to 2 N/T 6/60 watt, and air fuel or fuel air ratio. So the formula to calculate the mass flow rate of the fuel is given as pi d1 square plus d2 square into rho L capital L upon 40. Okay, this is the mass flow rate of air. So the formula to calculate the mass flow rate of air is given as follows. Now brake specific fuel consumption. Brake specific fuel consumption is the ratio of mass flow rate of fuel upon brake power. Now brake thermal efficiency. Actually, brake thermal efficiency is the ratio of brake power upon heat supplied by the fuel, and heat supplied by the fuel is MFLCV. LCV is lower calorific value of the fuel in kilojoule, and higher the value of brake thermal efficiency, greater will be the brake power, and brake thermal efficiency gives us an idea of power output generated by the engine with respect to the heat supplied in the form of fuel. If the thermal efficiency of the diesel engine is high, it means the diesel engine is doing its job very efficiently. And volumetric efficiency, it is the ratio of air intake at atmospheric condition upon shift volume. Now heat balance. Heat release from the combustion of the fuel is given as, and this heat which is releasing from the combustion of the fuel will be given as this formula, and some parts of this fuel energy will be used to utilize the brake power or useful power, and some part of this energy will be carried away by exhaust gases, and some parts of the fuel energy will be lost in radiation, and some parts of this fuel energy will be lost in coolant. Now result and discussions. These are the graph. This is the graph which is BP versus load, and it is noticed that when the load is increasing, the brake power is also increasing. And this is the graph brake specific fuel consumption versus load. So when the load is increasing, the brake specific fuel consumption is decreasing. And this is the graph brake thermal efficiency versus load. When the load is increasing, the brake thermal efficiency is increasing. Already we have shown in previous graph, when the load is increasing, the brake power is increasing, so thermal efficiency will be increasing. So this is the graph air fuel ratio with load. When the load is increasing, the air fuel ratio is decreasing. It means the fuel quantity in the air fuel mixture is decreasing, so the air fuel ratio is decreasing. Now this is the graph of volumetric efficiency versus load. When the load is increasing, the volumetric efficiency is decreasing linearly. And this is the graph between equivalence ratio and load. When the load is increasing, the equivalence ratio is increasing linearly. And this is the energy balance. We have already discussed about this energy balance. Some heat of this energy of fuel energy will be heat equivalent to the effective or brake power of the engine, and some part of the fuel energy will be lost in cooling medium, and some part of this heat will be carried away from the engine with the exhaust gases, and some part of this fuel energy will be uncounted losses. And this is the heat balance sheet, and this is the percent, which is Q fuel upon Q fuel into 100, Q brake power upon Q fuel into 100. Okay, this is the percent. Now this is the energy balance graph in which load is shown and percent of the energy is taken on the y axis. This percent is this one. Okay, and when the load is increasing, the percentage of fuel energy which is converting into brake power is increasing, this one. And when the load is increasing, the percentage of fuel energy which is losing in exhaust gases is decreasing. And when the load is increasing, the percentage of fuel energy which is losing in radiation is decreasing, and the percentage of fuel energy which is losing in exhaust gases is like this one. Okay, and there is no significant change in the initial value and the final value. And when the load is increasing, the percentage of fuel energy which is losing in coolant medium, this is this one. Okay, and there is no significant change in the initial value and final value of this graph. So this is the variation of the load. This is the variation of the load and the percent of the fuel energy. Now conclusion and future work. Following are the conclusions based on our experimental investigations. When our diesel engine is operating, and it is observed that the brake power is increasing, brake specific fuel consumption is decreasing, and the brake thermal efficiency is increasing with increase in load of diesel. We have already noticed from the graph. Okay, it is observed that on increasing engine load, the air fuel ratio decreasing. As the engine load increasing, the fuel quantity increases, thus the air fuel ratio decreases, and air fuel mixture becomes rich from lean. And this is for volumetric efficiency. And when the engine load increases, the equivalence ratio also increasing linearly. We have already noticed from the graphs. All these conclusions can be seen from the graph. And now talking of future work. Firstly, we used diesel oil in our diesel engine, and we tested the Kirloskar diesel engine, 4-stroke single cylinder. So now for future work, we have biodiesel and diesel biodiesel blends for the enhancement of performance of the diesel engines. And biodiesel can be used in the diesel engine as a fuel, and the diesel biodiesel blends can also be used in the diesel engine. So biodiesel can be added to the diesel at the proportional of 5% or 10% or 15%. So after after testing our engine, we will be we will be focusing on the emission characteristics of the diesel engine, because emissions from the engines are very badly affecting the mankind. So our future work can be conducted by using the biodiesel and biodiesel blends to upgrade the performance characteristics and cut down exhaust emission. So in our future work, we will be focusing on the emissions characteristics as well. And firstly, we used diesel in our diesel engine as a fuel. After that, we will be using, or we will be focusing on the other fuel like biodiesel and diesel biodiesel blends. And these are the references. Thank you very much.